So last time we talked about position, velocity, and acceleration. And one of the details that we did not really talk about is that each of those things have directionality, in that when we talked about acceleration, we talked about acceleration as positive going in one direction, and then deceleration as slowing down. But really what we're talking about is that each of these things have what's called directionality. And we represent that directionality using vectors. So let's talk about what vectors are. Vectors are things that have both a magnitude and a direction. So if a car is driving from point A to point B at a certain speed, then we say that its vector is AB, and its magnitude might be something like 4 miles. So this point A to point B could be, for example, eastward, and it's like 4 miles or 4 kilometers. Let's say 4 kilometers eastward. If the car is going from B to A, then the vector is westward. So it's opposite of eastward, but it's still 4 miles or 4 kilometers. Vectors can be in any direction, so they don't need to be east-west or north-south. They could be northeast or northwest or something like that, and they could be in any direction. The magnitude could be any magnitude also. The vector just represents a direction and some sort of a magnitude. So one of the natural ways for us to think about vectors is using a map system, because most of us have looked at a map and we know that there's east-west and north-south. And so when we're orienting ourselves, we orient ourselves in east-west and north-south coordinates. And so if we're driving around in our car or on a bike or moped or whatever, we think of driving in an east-west direction or a north-south direction. And a map sort of shows us that. And these are all vectors. We also have a third dimension. Up is a third dimension. On a map, we don't think of there being a third dimension unless it's like a topography map that shows like contours of elevation and stuff like that. But up is definitely a direction. And when we think of rocket science, we're going to be using up a lot. But we basically have 3 directions. We live in a 3-dimensional world, so we have 3 dimensions. And we think of them as north, east, and up. So let's take a car, and let's say that our car is driving eastward for a bit, and then it's driving southward for a bit. So what we can think of is the car is moving in the eastward direction, and then it slows down and stops, and then it changes to the southward direction, and it accelerates in the southward direction. So we actually have like velocity in the eastward direction, and then it's decelerating and stopping. Then it turns in the southward direction and accelerates in the southward direction. But in some places, there are roundabouts. And so you can have a car that is driving around a roundabout. Let's say that you're lost and you don't know which direction you're supposed to be going. So you just stay in the roundabout and you keep driving around the roundabout. Well, the interesting thing about the roundabout is that it's a circle, right? And so you may be driving your car at the same speed around that roundabout, constant speed. Say that you're going 20 kilometers an hour around the roundabout, but your direction is changing all of the time, okay? And that, because your direction is changing, that actually means that you're accelerating, because your velocity, which has both a direction and a magnitude, is changing in time. So as you go around the roundabout, your velocity is changing because your direction is changing. Speed might not change, but direction is changing. And that's sort of a fundamental concept that we're going to come back to when we talk about orbits. Let's talk about gravity for a second. Gravity is a vector. Gravity operates in the up-down direction. It doesn't operate in the east-west direction or the north-south direction at all. It only operates in the up-down direction. And that's really fundamental for rocket science also. There is a disconnect between the vertical direction, which gravity operates in, and the horizontal direction, which gravity does not operate in. And those things are separate then, and we can think of them separately because of gravity being a vector. So let's think about what things are vectors and what things are called scalars. Vectors have directionality. So acceleration is actually a vector. So gravity operates in the up-down direction. When we change velocity, we could change velocity in our east-west direction or our north-south direction. So velocity is a vector. Position is a vector because you can go east or north or south. And so you could think of like a house number as being a position. And so that house number goes up or down depending on whether you're going north or south on a street or east or west on a street. And so position is actually a vector also. And we haven't really talked about forces, but forces are vectors also. And that will be quite important when we actually do talk about forces. Scalars, on the other hand, are things that don't have directionality at all. So when we think of temperature, we don't think of that as having some sort of direction. Like there's not an eastward temperature and a northward temperature. It's just temperature. And the same with pressure. Pressure is a scalar, so that doesn't have an eastward pressure or a northward pressure. It's just pressure. And things like constants, like pi, 3.14159, that doesn't have directionality either. That is just a scalar quantity. So in summary, scalars describe the magnitude of something, while vectors describe both a magnitude and a direction. They have directionality. Gravity is a vector, and that's going to come up as a basic concept for rockets. Gravity works in the vertical direction. And so gravity works in the third dimension, the vertical dimension, and it's completely disconnected from the northward and the eastward direction. And this is a fundamental concept. So in the next lessons, we'll talk about the fact that gravity works in this vertical direction and what effect that actually has on ballistic motion of rockets and stuff like that. So until next time, thank you very much.